Hello, everybody. Thanks for coming back to my channel here to take a look at my video on counting Sig Digs. So when I'm talking about Sig Digs, I'm talking about significant digits. Also, sometimes you'll hear this called significant figures or Sig Figs. We're talking about the exact same thing. It's just different notation. I like to use Sig Digs because I'm referring to digits, and that's kind of the way that I teach with measurements. In my previous video that you might have watched, we talked about the digits in the measurement, and so we're talking about the significant digits of that measurement. Oftentimes, especially maybe coming from chemistry class, we do a lot of significant figures, significant digits in chemistry, and you maybe come away with the idea of, well, why is this important? Why do I need to do this? And sometimes the explanation isn't always the best. So hopefully here I can explain that a little bit more of why it's important for us to worry about these sig digs in a measurement or just in general for science. With all of our measurements, we have an uncertainty. We have some guess, right? That for us, if you go back and watch my previous video, rule number 3 is that we always get a guess digit. That means there's some part of our measurement that we don't know. There is always something that we don't know. And by using sig digs, we can communicate that part of our number that we don't know, right? Our recorded measurement, we don't know some stuff. We don't want to go deeper than what we know. We don't want to go past that unknown. For example, let's say we had 2 measurements. Let's say we measured a square. And we measured that square to be 1.5 inches by 1.5 inches. Okay, so we happen to get the exact same measurement there. Again, that 5, that 0.5, is our guess digit. The 1 we know for sure, but the 0.5 we are guessing. Now, if we wanted to solve for the area here, we would take the length times the width, which would in this case just be 1.5 times 1.5, which would then be 2.25 inches. So notice here my area measurement, and sorry, it's not 2.25 inches, it's inches squared there. But anyways, the more important thing that I'm focusing on here is that notice my guess digit before was in the tenths place, the first decimal place for both of my measurements. But now I've gone past that and I have this 5 there, right? So that 5 is beyond what I guessed, beyond the uncertainty of my measurements. So I've become too precise here. And so in some ways we can just round this, but it's important to know that because we don't want to communicate anything beyond what we know. We don't want to say, I know this for sure, when you don't actually. And that's where sig digs come in. We communicate the fact that, hey, I'm limited based on my tools. I'm limited to this amount of knowledge, this number, many numbers of digits in my measurement. I'm limited to that. And therefore that affects everything from there. So this comes up in labs and everything. You don't want to communicate beyond what you know because there is always uncertainty and it always goes really deep there. So let's keep on looking here. For measurements in general, number of sig digs is actually super easy to work with. It's the number of known digits plus the one guess digit. So everything that we know plus the one guess digit. Now, where things get tricky with this is sometimes people want to say, well, I know for sure these zeros, those are known measurements. Well, not exactly. They're not really things that we know. It just depends on the scale that we're measuring with. And it's kind of weird to say, but it's just like saying, without that decimal there, right? It's just like saying, if I wrote the number 100, I wouldn't put all of these zeros here. We can put an infinite number of zeros out in front. And so we have to kind of be careful about what exactly we refer to as the known. And so we're just going to put some specific rules here for what we count as a significant digit for not only our measurements, but also just any number that you're given. For example, if you're given a number on a test and it says how many Sig Digs is this number, you can use these rules to count the number of Sig Digs. So that's what we're going to do in this video. In a future video, we'll go through some examples, and maybe we'll talk about as well how to handle mathematics with Sig Digs, addition, subtraction, multiplication, division, because that's where things can get a little tricky. But in this video, we're only concerned about how to count those Sig Digs. Let's keep scrolling here. There we go. All right. So counting Sig Digs, rule number 1, all non-zero digits are always significant. So if a digit in your number, in your measurement is not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's always significant. Okay, so anything that is not 0 is always significant. And again, it's always. So that's why we have to be careful with our measurements, that we write down just that one guess digit, because then we mess with the number of Sig Digs that we should have and all that. Anyway, so what this means is that zeros become the tricky ones. Zeros are the hard ones to work with Sig Digs. And so we have some more rules dealing with zeros. So rule number 2, this is the sandwich rule. All zeros that are between two non-zero digits are significant. So looking here, these are 2 examples of the sandwich rule. So I've got 2 non-zero numbers, 3 and 3, and I've got 1, 2, 3 zeros sandwiched, smushed between those 2. So that means all of these are significant. I have a non-zero. According to rule 1, that's always significant. So there's 1 Sig Dig. Again, I'm talking about the same thing. 1 Sig Dig, 2 Sig Digs. So then these zeros in between must also be significant. So there's 3, 4, and 5, a total of 5 Sig Digs in this number. Taking a look at this next one, a little bit more straightforward. We have 2 non-zero numbers, a 4 and a 5. And then there's 1 0 in between, so that 0 must be significant, giving us a total of 3 Sig Digs in this number. Let's take a look at rule number 3. Rule number 3, I kind of briefly mentioned this before. Leading zeros are never significant. So any 0 that is out in front of a number is not significant. Doesn't matter how many there are. All of these zeros there are not significant. These 3 zeros are not significant. That 1, that 3, and the 4 are the significant digits in this case. Leading zeros are usually what we call, they behave like placeholders. So they're not significant. They are important that we have them, especially for decimals, because they communicate the place, the digit that matters, right? So this one's long. Let's look at this one, the second one here. Without these zeros here, maybe I would just write 34, right? And then maybe there's no decimal, or I put the decimal there, and now the 3 is in the 10th place. But the 3 is not in the 10th place for the measurement. The 3 is in the, well, this is the tenths. This is the hundredths. This is the thousandths. So the 3 should be in the thousandths place of this measurement. So these zeros here tell me where those measurements are happening, what scale they're on. So they're still important, but they're not what we call significant figures or significant digits. They're placeholders. 2 more rules here. Ending zeros. Ending zeros are only significant when there is a decimal point. Without the decimal point, those ending zeros are still, like with the previous one, are still placeholders. They're telling us the position, the value of the number. So this very first one here, this is 300, no decimal place here, right? No decimal point, rather. No. decimal point. So those two zeros are not significant. They're placeholders. They're holding the place for the ones and the tens. So I know for sure it's 300. You'd be pretty upset if somebody gave you $3 when you were told that you were going to be getting $300, but they say, oh, it's not significant, right? It's kind of that idea. These placeholders hold that value there, right? 3 and 300 are not the same thing. So these zeros are important to be there, but they're not significant. But by adding this decimal on the end, even without any zeros after it, these two become significant. So if my measurement needed to be 3 sig digs, or my calculation needed to be 3 sig digs, and I got the answer 300, I would do 300 and just a decimal point. And that gets me 3 sig digs. 1, 2, 3. Now we can go beyond this, and any decimals after the decimal point, or sorry, any zeros after the decimal point, are significant as well. Any zeros at the end of the number are significant, even when there's a decimal. So when there is a decimal, not even when there is a decimal. I keep misspeaking. I apologize. So 300 decimal, all those zeros is a total of 6. 1, 2, 3, 4, 5, 6. This also applies, let's say, if I had 3.6210, this zero is significant. 1, 2, 3, 4, 5. This would be 5 sig digs here. Okay, so any zero at the end of a number is significant when there is a decimal point. This is one of the easiest ones to mess up and forget about. Let's take a look at the very, very last one here. Rule 5. When writing a measurement in scientific notation, all non-significant zeros are dropped. This one is a little tricky sometimes. Scientific notation is this kind of a notation right here. Oftentimes you'll see it for different numbers that are very, very, very large or very, very, very small. So either 10 to like the 10th power or 10 to the negative 10th power, something like that. But it always has some number multiplied by 10 raised to an exponent. That's significant. Scientific notation. Scientific notation. We drop anything that is not significant there. So leading zeros, ending zeros that aren't significant, we drop those for scientific notation. We only put what's important. So let's say here, my example, we measure 3,000 glugs, where the hundreds place was the guess. Well, the hundreds place is this one right here, this first zero. Thinking back to what we talked about, we're all known plus our one guess digit are significant figures or significant digits. Then in this case, we have 2 significant digits. And these 2 zeros are not significant. So if I write this in scientific notation, I only keep the significant figures, 3 and 0. I don't include those other 2. And then multiplying by 10 to the third is moving that decimal point 1, 2, 3 spaces. So I end up with the number 3,000. So that's rule 5. For my classes, I don't use scientific notation all that much, and we don't use scientific notation all that much, but it is something that does come up from time to time, and it is something you need to be aware of. Again, for now, the most important thing is that we're understanding how to count sig digs. If you feel like you're not understanding, check out my next video where I will go through some more examples of counting sig digs and using all of these rules to determine what numbers, what digits are significant. But for now, thank you for taking the time to watch, and I hope you have a wonderful rest of your day.